we are given a triangle ABC, which is displaced with some vector v, and we know the vertex A prime from the new triangle, so from the image triangle. Now, to solve this exercise, well, you can actually solve this exercise purely mathematically. There's no need to draw the triangle accurately in a coordinate system or anything. You can do that if you want, but it's not really necessary. It's enough to draw a little sketch like here. So here we see the original triangle ABC with the coordinates, and we know that it's displaced to some triangle A prime, B prime, C prime, and the coordinates of A prime are given. So we are looking actually for this displacement vector here. That's the displacement vector v that we want to find. And once we have that, we can then figure out the coordinates of B prime, C prime. So the displacement vector v, well, that's just the coordinates of A prime minus the coordinates of A. So it's 2 minus 2, then 1.5 minus 2.5, and minus 1, or 4, this one, minus 1, and we calculate that, and we will get 0, minus 1, 5. And that's a displacement that occurs from A to A prime. So 0 displacement in the x direction, then minus 1 displacement in the y direction, and 5 units displacement in the z direction. Okay, now once we have that, we can also calculate the coordinates of C prime and B prime. So for instance, for B prime, well, if B is displaced with this vector, then in x direction we add 0, so it stays 6. In y direction we are at 8.5, we subtract 1, so we are at 7.5, and in z direction we are at 1, add 5, we are at 6. So this is B prime. And then for C prime, well, here again we're at minus 2, add 0, stay at minus 2 in the x direction. Y direction 3.5 minus 1, so 2.5, and then the z direction is 0, we add 5, we are at 5. And so we have all the coordinates of this image triangle. And you would find also this vector v here as well as here. Okay. Now you could, if you want, also draw this then in a coordinate system. I think actually the exercise says that you should draw it in a coordinate system. So if you have your coordinate system, it would look somehow like this if you draw that. And then in exercise B, well, in exercise B, you just have the opposite exercise, kind of. Now you have the image triangle D prime, E prime, F prime given, and one vertex from the original triangle, so D. And you want to find the other vertices E and F of the original triangle. So again, you have to figure out the displacement vector that displaces the original triangle to the image triangle. And again, we can easily find this out by looking at the difference. So in x direction, it's 3 minus 5. In y, it's 2 minus minus 2. And in z, it's 0 minus minus 3. And so we end up with the vector minus 2, 4, and 3. Okay, so that's our displacement vector v. Now, all we have to do is, well, we could subtract this displacement vector v now from f prime and d prime to get f and d. And what we can also do is we can look at it basically in a way that we say, well, if v displaces d to d prime, then the opposite vector minus v will displace d prime to d. So we can look at the opposite vector minus v, which is 2, minus 4, minus 3. And in this case, the opposite vector is then the vector that displaces, that's minus v, and this would also be minus v. So we can just add minus v here. So for f, this would then be, so in the z direction, minus 3 plus 2, you're at minus 1. Then 4 minus 4, you're at 0. And minus 1 minus 3, we're at minus 4 for f. And for e, again the same, minus 4 plus 2 is minus 2. Then 0, we move minus 4 in the y direction, so we're at minus 4. And for z, we're at minus 3 and move minus 3 in the z direction, so we are at minus 6 in the end. And so finally we have our coordinates of the original triangle.